Okay, so this video, I'm finally going to get around to using all this stuff that I built to actually validate my answers to the previous problems. But briefly before I do that, I just want to demonstrate this one last thing that I've made, which I've called a generator runner. So you take one of the things that we saw previously, right? Every one of them has a method called next, and also every one of them has a field called end reached. And so just to kind of simplify my, every time I call that to get to count up something with a property passed in, basically the only thing that's really important here is that it has a method called count, and you input the property that you'd like to count up, and it even has a method that says show instances so that you can peek at, right, tell me the index of a few of the things that you want to look at, just to directly visually confirm that it's generating the kinds of things that you want it to generate. And then it basically builds a counter and runs until the end, so that and then returns the output of the counter. So this is just a way of kind of cleaning up the process of counting up the things with the property, basically. Now, significantly later on, so I'm not presenting this in the most sensible sequence, just because you know, I built these things in you know, various orders or whatever. So anyway, the point is, here you see, right, I just made a thing that allowed me to make decks, right? So you input a suit size and it outputs a permutation generator representing the permutations of the cards in a deck of the given size, basically. I eventually decided to look at a deck of 8 cards, and then later on I'll look at a deck of 12 cards, and it turns out that the deck of 12 cards, when I run it, requires 72 minutes of computation, and so I dare not run it on a deck where there are 4 cards in each suit. So although this does solve my problem of memory management, and I can certainly do things with this that, you know, my earlier code just couldn't handle because it would run out of memory. I don't have the patience to run it on something truly gigantic. I think for that I would really need a supercomputer. So anyway, okay. So let's see what happens and how I use this to validate my answer to exercise number 1.1.6. So the deck was a permutation. When my deck has size 2, right, and here I have this general property of the spades being consecutive, and the way, right, it's worth seeing how I represented that, because one thing that might still be very confusing is that if these things are just lists of numbers, and maybe we believe that there are, right, for every sorted deck, there is a corresponding sorted list of numbers. By sorted, I mean like where we consider that the order matters. So even if we believe that there's this correspondence between decks and lists of numbers, how do we actually sort of decide which ones are the ones with consecutive spades in them? Well, somewhat arbitrarily, you can just declare that the first 1/4 of the deck is all the spades, right? So that would just be the numbers, you know. So here, like, right, if I say that each suit has 2 cards, then index 0 and index 1 are my 2 spades, and everything else is not spades. But anyway, so, and then what I want is I want those to be consecutive. And so the way that I check for that, right, is, okay, fine, I mean, I do a little bit of basic math just to talk about how big a quarter deck is. And then I basically increment through all the cards in the given deck, right? This deck is going to be a list of numbers, and I take every index, and I look at what is in the deck at that index, right? So deck at this card index is going to take the deck, go to the index, and find the number which is there at that index, and that number is supposed to represent one of the cards. Well, what I want to do is I want to say the first time that I do this, if I find a number less than the quarter deck, right? Because every number less than the quarter deck I'm sort of taking to be how I represent the spades, right? So the ones that are less than quarter deck are the spades. And I say, okay, as soon as I find my first instance of that, I then want to take every next thing of the appropriate length, right? So from 1 until quarter deck, right? I want all of those to also be right within the appropriate range. And I found the easiest way to say that is, well, if it's outside the appropriate range, then declare that the deck gets mapped to false. It does not have consecutive spades. But if you get all the way through the check and everything works out fine, you never return false, then return true, because it must have been that all the spades were consecutive in order to reach that line of code. So that defines my consecutive spades. I generate I get my runner for a deck of 8 cards, and I basically just wanted to see the instances from whatever that is, 10,000 to 10,005. And I ran it, I got a number, and I believe if I were to amend my solution to problem 1.1.6 and compute it explicitly, it would give me the same number. I don't show that here because I also kind of did it all over again with a deck with 3 cards per suit. Ran it all over again, this time gave myself a smattering. Oh, by the way, I did want to just point out, look at this, right? 1 is next to 0, right? 0 next to 1, 1, 0, 0, 1. I'm just pointing out that in fact, right, it is, right, I get to explicitly look at the things that it's generating and confirm that it is the way I expect them to be, based on everything that I just described. And then over here, right, I would want 0, 1, and 2 to all be next to each other. And when I peek at various points within the generation, I see that 0, 1, and 2 are next to each other. And especially as I get way out into the sequence, then it's quite, as you would hope, not always in the same order, but they're next to each other. So it is generating the things that I would have, it's showing me what I need to see to confirm that it's really doing what I intended to do. When it counts them up, it finds this number. When I amend my formula, which was the solution to this exercise 1.1.6, I compute exactly the same number, and I know that my answer was right. In the next videos, I'll just show how I did the simulation for the remaining problems.